Okay, for part A, I'm supposed to put my tick marks everywhere there's a dot. So I already have a table with X values across the top and my values down the side here. And then I point Y value this 2. I plugged in up Y, this X value of 0 in there for that X, and that's where -4 comes in. So over here at 0, 2, I have a -4 slope, so I make a -4 slope. At 2, 2, I have a positive 4 slope. I have a -1 slope here at 0, 1, positive 1 slope here, 0 down here. So you had to put 6 marks. There's no marks on 1. You wouldn't put anything there. And besides, those would all be undefined slopes, and you don't put on your fields. So that is part A. Part B says, let y equal f of x be a particular solution to the diffie-q with the initial condition 2, 3. So there, right there, 3. Write an equation of line tangent. So we want the equation of the tangent line at x equals 2. Well, we're going to use that same point they gave us, 2, 3, that they gave us over here that I underlined first here. And now we have to find the slope. Well, the slope is this diffie-q up here at the top. So you're going to plug in 2, 3 into the problem. So we get 3 squared. That's the 3 down here, that y value. And then plugging in your 2. End up getting the slope ends up to be 9 over 1, which is 9. The equation of line is going to be y minus 3 is going to equal 9 times x minus 2 from point slope formula. And then it says, what is this going to give you to approximate if x is 2.1? So we are supposed to plug 2.1 into this tangent line right here. So I'm going to come up here to the left. Get y minus 3 is going to equal 9 times 2.1, plugging that value in, minus 2. Minus 3 is going to equal 9 times 0.1. It's going to be, I'm going to add my 3 over, and that's going to be plus 0.9, which will give me 3.9. So my approximation is 3.9 for that problem. That's part B. Okay, part C says find a particular solution. So that means we're going to get the equation to the different equation, same 0.23. You're going to come back up here to this diffie. First, have to separate our x and y. So we have to divide by y squared to put that over there with the dy. And then we have to multiply by dx to get the x's all on the right side. And now we are going to integrate each side. Well, you are not allowed, again, some of you, I'm going to repeat this, try to do natural log of y, do natural log when you have a variable power. So we need to move that 2 in the bottom up to the top by changing the sign. Then we got to do u substitution and let u equal x minus 1 because x is to the first power. So du is going to equal dx. So then this is going to equal the integral of 1 over u du. So we do have the natural log on the right side. Over here, we're going to the left side, we're going to add 1 to negative, which gives -1. And when that's going to be over -1. And then over here, we're going to have the natural log of the value of plus some c. Okay, then we are going to take, and we are going to go ahead over here on the left side and rewrite that as -1 over y is going to equal the natural log. And then we're going to put our x minus 1 back in for that, plus c. Okay, and our point again, 2, 3, is that point in, and we're going to get -1/3 is going to equal the natural log of 2 minus 1 plus some c. That's the natural log of 1, which is 0 here. So that means c is going to be 1/3, -1/3, sorry. So erase it. And I'm going to plug in my C into my equation that's up here on this top right side. And then I'm going to solve that for y. So I get negative 1 over y is going to equal the natural log of minus 1, and then I plug in that negative 1/3 for c. I've got to take that and do algebra and solve that problem for y. So what I think I'm going to do is I'm going to multiply each side by negative 1 to get rid of the negative over here on this left side, and that's going to make that third positive, make the natural log part negative. And then I'm going to flip both sides upside y by y is going to equal 1 over 1/3 minus natural log of x minus 1. And that is good enough for our equation. So if you have any questions on that, let me know. See you next Friday.